All right. Good morning, everyone. So we are going to start chapter 3. I am going to talk about your test 1 in the next class, and the answer will be released so you can see which question you missed. Just want to let you know that you all did good in test 1. The class average for test 1 is 89%, and which is fairly good. And again, once the test is released, you can go back and look at the questions that you missed. And if you need explanation on those questions, feel free to ask either me or Ms. Minion. Just take a look at the test first, and it will be released either tomorrow or on Wednesday. And an announcement will be sent once the test is released. Then you can take a look at your questions that you missed, go over that, and if you have any question or you need further explanation why your answer is not correct, just let us know and we will go over that. So let's start chapter 3 today. Any questions for me before we start? All right. If not, let me start chapter 3. So in chapter 1, we talk about producing data. We discuss the distribution in chapter 1. In chapter 2, once we know what kind of distribution we have, then we look at their relationship. And in chapter 3, we are going to talk about how do we produce data. So first chapter, we talk about the distribution. What are the individual variables? How do we represent them? We talk about density curve. We talk about normal uniform distribution. In chapter 2, we talk about bivariate data set. We talk about explanatory and response variable. Then we look at the relationship between categorical and numerical data set. In chapter 3, we are going to talk about how do we produce data. So what are the good ways of producing the data, or what are the ways that we should not use or we should be careful when we are producing the data? So that is our chapter 3. So chapter 3, we are talking about producing data. So in chapter 3, we are going to talk about sources of data, where the data comes from, how do we do the experiment, what are the good experiment. Then we will also talk about sampling design and 3.4 ethics. We will talk about that, but we will not spend too much time on this. And this topic will not be covered in any of your homework assignment or in your quiz or in your test. Not in your homework, quiz, or test. But again, we will talk about this. So in real life, if you are collecting or if you are producing the data, you are collecting using sampling and doing some experimental design, then you need to know these ethics or rules before you collect the data. So sources of data, 3.1, where is the data coming from? Or when we are talking about data, what kind of data set we are talking about? So we will talk about anecdotal data, available data. Then we will talk about how do we get the data by doing the sampling, and which is another like 3.3, we are going to talk about how do we do that sampling, what are the good ways of doing sampling, what are the things we need to consider when we are collecting the sample. And then we will also talk about how or what is an observation study, what is an experiment, how do we differentiate between observation study and experiment, and confounding, and you can write lurking variable. We talk about confounding and lurking variable in chapter 2. And in this chapter, we are going to talk about if there is a confounding or lurking variable in your experiment, then how do we control or how do we do the experiment such that the effect of lurking and confounding variable can be controlled. So this is in 3.1. So let me just quickly talk about these definitions and explain what does that mean. So when we say anecdotal data, what is anecdotal data? When we talk about something that is unusual in certain way, then we say anecdotal data. And what does that mean? So it says that anecdotal data represent individual cases that often come to our attention because they are striking in some way. So we can say that, let's say, if I see the weather today outside and it's like, oh, last time when the weather was like this, last year or 2 years back or 3 years back, it was a heavy rain for the whole week, or there was snowstorms or hurricanes. So that is just because of my personal experience. So when we are talking about anecdotal data, they are the represent individual cases that are often come to our attention because they are striking in some way. But that does not mean that is usual or that is applicable for everybody. So we tend to remember these cases because they are unusual. The fact that they are unusual means that they may not be representative of any larger group of cases or individuals. So that is, what do you mean, or what do we mean by anecdotal data? And it says that be aware of drawing conclusion from your own experience. When we are saying on our own experience, my experience will be different than your experience. Your experience will be different than somebody else's experience. Available data, and nowadays we say that, okay, I want to do some work and I need to analyze some data, and let's say that data is available on Google or other. So when we say available data, when that means that the data is produced in the past for some other purpose, but it is available for us to further analyze or use and to find our present question. So then we call it available data. The data that were produced in the past for some other purpose, but it may help you answer a present question, and again, inexpensively. That means you don't have to pay anything. When you are collecting the data does not come for free. You need to spend your time and money to collect the data. And if we are talking about available data, that means you can use that data without paying. And if you see, all the data is not considered as available data. We have private data set. We have on internet, you do not see the data available for every single thing. So available, that is free and easy to assess. We are talking about available data. You can find that in the library, and internet is a good source for available data. So when we are talking about available data, and I need to look, I need to study how, let's say in UNCG, what do students want to do, or where do UNCG students, how do UNCG students spend time on on their weekend? So if I want to work on that, and if I need to see how many UNCG students are spending time on library, movies, gym, study, visiting places. So that means I need to collect that data. Not necessarily that data is available to me. And when I am collecting the data set, then I am doing sampling. And again, when I'm doing sampling, I need to do in such a way that my sampling does not cover from bias. And when we say bias is basically when we are doing systematic favorism of particular outcome. So we need to consider all those things. And some questions require data produced specifically to answer them. And that time we need to collect that data set. And then once we collect, or when we worked on sampling, then we will design our observational study or experimental study. Now we are talking about observation and experimental study. What are observation studies and what are experimental studies? So let me talk about this first. When our goal is to understand cause and effect, when you are looking for if there is a cause and effect relationship, and in last chapter we talk about correlation does not imply causation, but there is causation. So there, when we are looking for cause and effect relationship, then we need to work with experiment. and what is an experiment, or how do we conduct an experiment. And when we are saying experiment, then how is observation study different than experiment, or how they are similar? So the distinction between observation study and experiment is one of the most important in statistics. Observation study, when you observe the results, but you cannot manipulate those results, or when you cannot apply any treatment to them, then we are talking about observation study. And read the word observation study. So you can observe. So you can observe individuals and measure variables of interest, but you cannot manipulate, or you cannot attempt to influence the response. So the purpose is to describe some groups or situations. So when we are talking about observation study, you can observe and measure, but you cannot manipulate those results. When we are talking about experiments, so in experiment, we are looking for cause and effect relationship. So we are applying some treatment to individual and see if that treatment is applicable, or if that treatment is giving me the results that I'm looking for, or is it giving me a different result. So then we are talking about experiment. So experiment impose some treatment on individuals to measure their response. And while this is not the case in observation study, you do not impose a treatment. The purpose is to study whether the treatment cause a change in the response. So again, when you are looking for a change or cause and effect relationship, experiment is the only way to work with. If we are looking for cause and effect, we go with this. If we want to observe the results and use those results, then we are talking about observation study, but we are not imposing a treatment on that. So experiment do not just observe individual or ask them question. They impose some treatment in order to measure the response. In observation study, you observe, ask questions, but you do not impose the treatment. And again, we will talk about why do we impose the treatment. We mentioned that we talk about two type of variables in chapter 2, confounding and lurking variables. So we need to control the effect of confounding and lurking variable. So we deliberately impose treatment so that we can control the effect of confounding and lurking variable. That is one way. We will talk about more ways how to do that when we talk about experimental design. What are the good ways of experimental design? Then we will talk about that. Okay, so one more thing. We are going to talk about, so this is sources of data. We talk about this. So design of experiment and sampling design. First, I will talk about 3.3 because we will use 3.3 and 3.2. So let me just talk about sampling design, or how to do sampling, what actually sampling is, how sampling help us, what are the good ways of doing sampling, what are the bad ways, or you can say what are the cautions we need to do when we are working with sampling. So for now, I'm skipping 3.2, but I will come back to 3.2 once I'm done with 3.3. So let me just talk about this, and then I will start 3.3. Sample surveys are a special type of data collection that usually aim to discover the opinion of people on certain topics. In a sample survey, a sample of individual is selected from a larger population of individuals, and we will talk about it in a minute. One can study a small part of population in order to gain information about the population as a whole. And conclusions drawn from a sample are valid only if the sample is designed in a well-defined way. So in 3.3 and 3.2, in 3.2, we will learn how a sample will be designed in a well-defined way. And in 3.2, we will talk about how do we do that, how do we use that sampling when we talk about experiments. And these we already discussed in chapter 2, so let's quickly go over with that. Observation studies of the effect of one variable on another often fail to establish cause and effect because of confounding between the explanatory variable and one or more of lurking variables. And if you remember, we talk about confounding as mixed and lurking as hidden. So there is a hidden variable, and we do not know if the effect on y is because of this x or my hidden variable. And that hidden variable is your lurking variable. So if you do not know the response on y is because of x or because of the lurking variable, we are talking about confounding variable. And again, hidden variable is lurking variable. It is neither in x nor in y, but it is affecting your y. So we are talking about lurking variable. So lurking variable is a variable that is not among the explanatory or the response variable. So it is neither in x or y in a study, but that may influence your response variable. Confounding occurs when two variables are associated in such a way that response on y you cannot differentiate it is because of x or it is because of your other explanatory variable, which is we call it lurking variable. Their effect on a response variable cannot be distinguished from each other. Is it because of explanatory or lurking variable? So it is a mixed effect of both. So we cannot say it is just because of X or because of a hidden variable. And this is what we are going to learn in this chapter. Well-designed experiment takes steps to avoid confounding. So when we are talking about observation study, we are not applying the treatment. We are observing. But when we are talking about designing, then we will do experiments. And when we do experiment, what do? We apply treatment. And then we will avoid confounding in our experiment. So let me talk about 3.3 first. Questions so far? Anyone has any questions? All right. So sampling design. First, we are going to talk about population and sample. When we say population, what is population and what is sample, how they are different, how they are similar. When we are talking about population, it is entire group of interest. If I am talking about the student of UNCG, all the student in UNCG is my population. When I'm talking about a sample is a part of population. So I'm not talking about entire UNCG now. Now I'm talking a part of population from which we actually collect information. So again, when we are talking about sampling design, we are talking about a population. So we are talking about entire group of interest, but instead of taking the whole group of interest, we consider a part of that population, which is called your sample. And when we are saying sampling design, so that means we are working with the sample. So again, how to work, how to collect that sample so that that sample is free from bias. And then we will use different sampling techniques. Which one is better? Which one we should not consider? Which one we should be careful? So we will talk about that. And they are mentioned. Some are here: voluntary response, simple random sampling, probability sample, stratified sample, multi-stage, and some of the things that we need to be careful about. Probability sample, our next chapter, chapter 4, is we talk about probability. So that will talk about all the probability concept. But here we are just going to talk about what do we mean by probability sample. So if we are saying the sample taken using the probability approach, what does that mean? So first, let's just quickly talk about a few definitions. So the distinction between population and sample is basic to statistics. So first thing you need to know what population I'm working with, what is my sample. So when we are saying population in a statistics study is the entire group of individuals about which we want information. So whole group of interest. Sample is the part of the population from which we actually collect information. We use information from a sample, and what do? We draw conclusion about the entire population. So it is given here. This is my big picture, or you can say my entire group population. And from population, I take a small group and I work with that, or this, or this, or this. So if we all are collecting a sample from this population, not necessary that we all work with this sample. When we are talking about sample is a small group that is coming from this big population. And when we are collecting a sample, we are collecting a group from this big population. So when we are collecting a sample, not necessarily my sample will be same as yours. Maybe some of the observations are same, or maybe entirely they are different. So when we are collecting a sample, we once we get that sample, then we work on that sample. We in chapter 5, 6, and 7, we will learn about once we collect the sample, how do we work with that? How do we test that sample? Or how do we get the results from that sample? Once you get the results, what do we do with those results? So then we do the conclusion or we do the inferences about the population. Because we are talking about this population is big or unknown, so we collect a small sample, or depending upon how big your population is. So you collect a sample from that population, you work on that sample, do the test statistic, and again, we are going to learn one thing at a time. Then you will learn how to do that test statistics and get the results. So once you get the results, you use those results to talk about this whole population, and then we call it inferences about the population. So you work with this small group from this big population. So this is my big population. I work with a part of this population, do all the analysis or testing on that, and then I use my results to do the conclusion or do the inferences about this population. So if I'm talking about this big population taking this sample should be taken in such a way that it should not have either the effect of lurking variable, confounding variable, or you can say bias free. So you need to see a couple of things when you are talking about how to collect this sample. And when we say population sample, there is one more thing, we call it as census. And census is a procedure to collect information from all individuals in a population. So we talk about sample, we talk about a population, and then the next census. So a census is a procedure that collects information from all individuals in the population. So correctly, we are talking about sample, working on that sample to take the decision about population. So we are working with a small picture and then use this picture to take the results, to get the results, and use those results to talk about this big picture. So that's what we are going to learn in this 3.3, how to collect that sample. What is that sample means when we get that sample? How do we do the testing and all that we are going to learn in later chapter. In this chapter, we are going to do how to do sampling in a good way. And again, first it says how to sample badly. So again, you can think of that as cautions when you do sampling, because we are not doing bad sampling. So it just explains that if you are doing a sampling, make sure that you should be aware of these things and you should not consider these things in your sample or stay away from that. So, first it says the design of sample is biased. And again, we need to be careful if there is bias in our survey or not. And again, when we are saying bias means systematically favoring certain outcome. So, I think we all know what bias is in general. We are applying the same concept here. If we are talking about bias, so again, let's say if I am collecting a survey, how many students like statistic, and I'm just collecting a sample from my statistic classes, not, or you can say how many student like statistic in UNCG, and I'm just collecting a survey, or I'm just collecting a sample from my statistic classes. Do you think that will represent the population of UNCG as a whole? And the answer is no. Yes. The answer is no, because if you are in statistic class, some of you definitely taking it as a mandatory class and you need to pass this class for your major. But there are some students that really like statistics, or they are working in a field of statistics. So there are more chances people say that we like statistics. Or since I am asking you, because I am your stat or your statistic professor, you may likely to give a positive answer, yes, I like statistic. Because again, when we are talking, and I'm talking about the next step also, voluntary response sample, because you might feel like, okay, if I'm asking you in person, I should not feel like, oh, these students don't like statistic and they are in statistic class. Like, I'm just giving in a journal example. So again, when I'm talking about UNCG as a whole and just taking the sample from all statistic classes, then that will not represent the results of UNCG population as a whole. Then my sampling suffer from bias, because we are talking about some kind of favoritism. So again, when we are looking for a sample, or when we are collecting the sample, first of all, we need to look for, if my sample is suffering from bias in that case, then I should not take the sample from there. And the next, again, voluntary response sample, like I mentioned, if I'm just asking you, okay, do you like statistic? Yes or no? You might answer yes. You might answer no, but most chances you will answer yes. And the voluntary response sample consists of people who choose themselves by responding to a journal appeal. And again, when we are talking about voluntary response, sometimes people have, let's say, in class, I just ask you a question and people have strong opinion, or you can say that strong, again, you can say positive or negative. Let's say if I ask you, oh, who did you vote for in this general election, Democratic or um, Republican Party? Again, if you have strong opinion, you will say it. But some student, or you can say some subjects, might not have strong opinion. Again, voluntary response samples also suffer from bad sampling design, or you can say bias. So we need to be careful when we are talking about voluntary response samples. Now comes to convenience sampling. As the word says, convenience sampling. So if I think that word as convenience plus sample, so I can think of a sample that is collected according to a convenience of the person who is collecting the sample. So let's say if I need to collect a sample, same thing, UNCG students, what do they like to do on their weekend? And I collect, since I'm going to the library, and I thought like, okay, let me just collect a sample from here, because I don't have time to go to different places like gym, in the hallways, in the cafeteria, different places. Since I'm in the library, let me just collect the sample from there and use that sample to talk about the whole population, about UNCG. So I just went to the library, or since gym is closed, I went to the gym and I collect the sample. And then I talk about the those results and talk about the population of UNCG as a whole. And again, my sample will suffer from bias because I collected the sample according to my convenience. Because I do not want to go to different places, since I am in the library, I want to save my time. I don't want to go different places. I collected the sample from there. So that is my convenience. So that is called your convenience sampling. So again, convenience sampling is also considered as bad sampling design. All right. So when we talk about sampling, so first thing, let's talk about probability sample. And what is probability sample? So when we are talking about probability, we are talking about chance process, right? If I toss a coin, I know either I get a head or a tail. I don't know which one I get, but I know that the chances are 50-50, right? So they have equal chance. When we are talking about probability sample, or when we are talking about sampling, probability samples are the best sample to work with that eliminate your chances of bias. And again, when we are talking about probability sample, we are talking about equally likely or equal chance of getting that sample in your survey. And we also call it a random sampling. And we will talk about random sampling, and we will use table B, and that table is also uploaded on your Canvas. So we will talk about how to use table B to do random sampling. And again, random sampling, when we are talking about random sampling, we are using the chance to select a sample, the central principle of statistical sampling. So, write a note to yourself whenever we are talking about sampling, random sampling or randomization is the best way to collect the sample that eliminates the chances of bias. If I am collecting a sample, let's say in your class, we have 45 students, and I need to talk about the whole class, but I do not want to look at every single student's work. I just want to collect a sample of size 5 or 5 students from this 45 pool, and then work on those 5 students, get the results, and then use those results and talk about the entire class. Then how do I collect those 5 students? So again, when I'm talking about those 5 students, I am talking about doing a sampling, and that sampling should not be if I'll say, okay, raise your hand if let's say we are in face-to-face class, or let's say Zoom. Okay, let me know which 5 students you want to be in my survey. And first 5 students who send me an email or raise their hand, I will work with those 5 students. Then I am talking about again voluntary response, as well as I'm also doing convenience sampling because I do not want to collect the random sampling. And again, then my results will suffer from bias because I am not giving equal chance to every single student to get into my survey. So, how should I do my survey so that every single subject has equal chance? We can either use any software, and we can do 1 to 45, and then we can use the command to give us pick 5 out of 45. So that will pick 5, and that can be 3, 7, 9. So we can label 1 to 45 depending, let's say, how you are enrolled in my Canvas page or how you are enrolled on my Launchpad page, and I will label them 1 to 45. And then whatever 5 numbers I get, either using the calculator or the software, those 5 subjects are in my sample. And again, when I'm getting those 5, I am getting that using randomization technique. I am not picking those 5, or you are not volunteering yourself to get into the survey. I am getting through the randomization where all 45 student has equal chance of picking. Or let's say the easy way, I will write each name on a paper and label them 1, 2, 3 to 45 and put it in a box. And then I shuffle the box and then pick one name out, and that will be my first some sample in my survey. So first sample, again, when I'm saying I pick that one, I do not know whose name will be picked. All 45 subjects were given equal chance. And then once I take it, and then I can keep that name outside. So earlier I had 45 names. I picked one, I kept it on the side. Now there in the box, there are only 44 left. So let's start with n. My n is 45. Now I have n minus 1 because I started with 45. I pick one out, leave that out. So I'm left with 44. So n minus 1. Then keep one more out. Then I'm left with n minus 2 or whatever my n here now. Then 43, 42. So I'm giving equal chance to all the subject, and then these 5 are my sample, or these 5 are in my sampling survey. And then I collected those 5 using my randomization technique. I did not do my convenience sampling. I have not worked with volunteer sample. I work with randomization or probability sample when I'm talking about 45. So there are 45 students in the class. And what is the chance of getting you into the sample? So when we are talking about you into the sample, you are one out of how many? 45. So you have 1 over 45% or 1 over 45, 45th. So you have that percent or that many chances to get into the survey. And every single subject has 1 over 45 chance to get into the sample. That means I am talking about random sampling or probability sampling. So again, when we say a random sampling, we are talking about simple random sampling. So when we say random sampling talk about the chance process. And when we are using the word simple random sampling, we are saying that we are doing random sampling in a simple way. And then we will talk about stratified sampling. We will talk about multi-state sampling. We will talk about systematic sampling. So the first easy way, random sampling, how do we random sampling in a simple way? We call it simple random sampling. So random sampling, the use of chance to select a sample, is the central principle of statistical sampling. A simple random sample of size n, like I use 45, consists of n individuals from the population chosen in such a way that every set of n individual has equal chance to be in the sample actually selected. And your test 2 will be on chapter 3 and 4. So chapter 3 is more conceptual more conceptual chapter. And you will get mostly conceptual questions from chapter 3. So at certain point, if you think that something is not clear, please feel free to ask. And again, chapter 4, we have both concept as well as mathematical part also, because we will talk about probability or the chance process. So simple random sampling, again, when we use simple random sampling, we use table of random digits. Again, software calculator is the best way, because if we are working with, let's say I need to collect a sample of 1,000 or 10,000 or 20,000, then I'm not using the table of random digit, which we call it as table B. So if you're working with a smaller sample, and again, you have questions in your homework assignment where you have to use table B. So it's just for you to understand how to use table B. Again, in real, we do not use table B. We use technology depending upon what sample size we are working with. If we are working with a larger sample size, we are not going to work with this. In practice, people use random number generators by computer or calculator. And again, when you work with a smaller sample, you can use calculator. But if you're working with thousands or 10,000, then definitely you use computer, and it will generate random numbers to choose the sample. And again, when it generate, you need to give them how many, how many you want to generate, and it will generate in between that. And again, if you do not have technology handy, we can use table B. What is table B, or how do we use table B? So choose how to choose a simple random sample. Let me just talk about one thing before we go to this part. All right, I guess let me just use this. How to choose a simple random sample. So we have table B, and table of random digit is a long string of digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we are talking about 0 to 9, we are talking about one digit. But if we are looking at the sample and we are looking at the population in 2 digit or 3 digit, again, then we will label it in 1 or 2. And once we will use the table, it will make more sense. Each entry in the table is equally likely to be any of the 10 digits, 0 to 9. The entries are independent of one another. What is independent means? When we say independent, so that means table entries are not dependent on each other. So we talk about independent and dependent variable, but in here we are just using general rule. What is independent? That means knowing one will not affect the chance of the other one. So if I know my first digit is 0, it's not going to affect my chance of the second digit being 3 or 5 or 7. And knowing these two is not going to affect my chances of the third digit. So they are independent. And we are going to talk about that in chapter 4 also. That is, the knowledge of one part of the table gives no information about the other part. And when we talk about table B, how do we use table B? First, label. Give each member of the population a numerical label of the same length. Table. Read the consecutive groups of digits of the appropriate length of table B. And use your sample contains the individual whose labels you find. So let me show you first how table B looks like. All right. So if we look at this, this is our table B, and table B says random digit, table B. And if you look here, it says that line, and the line start like how we had Z score, similarly here line. So if the question specify which line I am looking for, I will just go to that particular line. If the table specify go to 103, I will just look for 103, and then I will follow this line. So I'm going to use only this line. And again, if I find my required sample in this line, I can just stop. And if I don't get, then I will just move to the next one. Now, how to use this line? So let's go back to an example. So this is the example that is given to us. So let me just fill that first. So let's say this highlighted part was missing because I converted this PPT into PDF to upload. So when let's just look at this. Let's say this information is giving to us. We have 28 hotels, and out of 28 hotels, we need to pick us 4 hotels as a sample from these 24. How do we pick those 4 hotels? So again, when you are working with randomization, every single hotel has equal chance of getting into your survey. So you have 22, so your population is 28, and you are looking for a sample of size 4. So you are picking 4 out of 28. How do we do that we all get the same 24, the same 4 hotels? So again, when you are using table B and using the same line, we all get the same sample. But if we all are using different lines, since we are talking about randomization, we all will get different sample. So if we all want to get the same sample from our population, how do we do? We use the same line in table B. And again, I'm mentioning this because you have questions in your homework assignment where you have to use table B using the same line, because the answer choices that are marked there are specifically only using that line. But in real life, you don't have to use the same line. If you are just looking a sample of size 4, you are doing randomization. So your sample might be different from mine, or maybe we have some same observation or some different. So when we are doing the random sampling, first step is again, I'm talking about in terms of your homework assignment as well as in real life. When you do sampling in real life, you do not have to arrange them in order. You can use the population and then you can label them though, because you need to see which subject or which subject should I take in my sample. So first thing is labeling. Here they'll first arrange them in alphabetical order from columns, and then they write it and then they label it. Again, here alphabetical order, first in columns. Again, you can do alphabetical in the rows, and then you can label them. But in your homework assignment and in the slide, first thing, you organize your data set, you organize your population in alphabetical order from column, and then you label them. And what is label? Again, when we differentiate how this is different than this, then we label them. And when we are labeling, we start with 1 up till whatever your last digit is. And then you see your last digit is 2 digit. And if I just say 0 here, if I just take this as 1 instead of 0, 1 or 2 or 3 or 4. So when I started with 1, 2, 3, 4, this is my 1 digit, but I end up with 2 digit. So make sure you make all 1 digit as 2 digit by adding a 0 in front. So 0, 1, 0, 2, 0, 3. So now you have all of them in 2 digit, 0, 8, 0, 9, and then 2 digit. But if your sample is only up till here, let's say if you have only these 9 observations or 8 observation, then you do not need to put 0. Then you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, because your last digit is 1 digit, or your last observation is 1 digit. Here it's 2 digits, so convert every single label into 2 digit. Once you convert into 2 digit, what's the next step? Now look for which line they are asking me to use in table B to get the sample. So they provided us a line here, and we will use the table also to see if we get the same or the different. So what do you do? First you label, and then since it's 2 digit, start drawing a partition after every 2 digit. And keep on doing. So now look at this, 69. Do you have 69? No. Do you have 05? Yes. And that will be my first sample. Do you have 16? Yes. And that will be my second sample. Do we have 48? No. Do we have 17? Yes. That's my third sample. Do we have 87? No. Do we have 17? Since we already picked 17, we cannot pick it again. So we will cross this out. You already picked one time, so you cannot pick the same hotel again. And same thing, 40, 95, then 17, 84, keep on going, and the next you get is 20. So when you look at here, these are the 4 hotels that is in your sample. So simple random sample of 4 hotels for the return to contact is this. And then we can use table B also, And again, this line comes from table B. I guess the time is over. So I'll stop here, but I will start back from here on Wednesday's class. Thank you, everyone. And if you have questions, let me know.
Thank you.
You're welcome. Have a wonderful day, evening, afternoon.